Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we check out variables on both sides of the equal sign. We're in the Common Core standard of expressions and equations, and today we're going to be using math properties that create expressions that are equal to each other, especially solving real-world problems having to do with math and equations. Our guiding question that we're going to be able to answer today is how do we solve equations with variables on both sides of the equal sign? So if you hear me say both sides, I mean, hey, you have an equal sign right smack dab in the middle, and you got variables on the left and variables on the right. All right, well, variables on both sides. We're going to be adding, subtracting, multiplying, and dividing. We're going to be using SADMAP, and we're going to be talking about sharks. Nah, I just put this picture in there because it's pretty cool. If you think about a shark and how fast it's going to swim, and you got another shark and it's swimming towards another meal, and they're both wanting to catch that same fish, and they're swimming, and one's swimming faster than the other one, how much time will it take for both of them to get there? Well, that's the kind of equation you can look at using variables on both sides. You deal with the train. Maybe there's two trains. You've heard a problem where there's two trains and they're going down on the railroad tracks, and one's traveling at a certain speed and the other one's traveling at another speed. How much time would it take for them to get to the same place? That's the kind of problem we'll be looking at today. Alright, well, I want you to look at these shapes here. Something special that we find out is that the area of each of these figures is the same as the perimeter. The area is the same as the perimeter. Alright, if the perimeter is the same as the area, the equations for the perimeter is the same as the area. So you've got easy one here, 3 times x, that's the area, but what's the perimeter? 3 plus 3 and x plus x, so that's 2x. So those two equations will actually equal each other. And that's the hint. You're going to try and create two equations that are going to equal each other for both of these shapes. Let's do it for all four. Let's do an example. Let's do that first one together. The perimeter equals the area, right? Perimeter equals the area. Well, the perimeter here on the first one is 3 plus x, right? And the area is just 3 times x. Now, when you simplify this, it comes down and you get 6 plus 2x equals 3x. Well, solve for x in a specific way. Notice we have variables on the left and variables on the right. Let's do this guy. We have the perimeter equals the area. Again, what's the perimeter here? We have 4 there, x and x. We get 2 times 4 plus x. You can write it a little bit differently. It's going to equal its area. What's the area? It's 4 times x. That's it. Notice we have variables on the left side of the equal sign and the right side. Okay, technically it's above and below, but no big deal. Why don't you try and do C by yourself? And D. D is the challenge one. See if you can pick it up. All right, remember, perimeter equals area. So find the equation for perimeter, make it equal to the equation for area, and you're good to go. So here, P equals A. So 2 times the quantity of 2.5 plus x equals the area, which is just 2.5x. Now D is a little bit different. You got two separate shapes there, so you got to find the area of each of them. Now notice with the perimeter, this line, this part right here, this 2 is not included in the perimeter, okay? All right, so for the perimeter, it's 1 plus 1 plus 2 plus 2x plus 1 plus 3. Right? This side is 3, this side is x, 2x's plus 3 plus 1 plus 1 plus 2. And then the area, got to add them together. Well, this area is 2 times 1. This area is x times 3. And that's it. All right? Now these cubes have a special property where their surface area equals their volume. Why don't you try and find the surface area of these two shapes and then make them equal to their volume? All right, remember, surface area equals volume. Surface area, you've got 2 bases times the perimeter of the base times x. It's the height. And the volume is just 5 times x. Remember, surface area again is you got the bottom base, top base, times the perimeter of the base, times the height. And here it is. Now you're not actually solving for x yet. That's going to come here in just a second. Now, what do we learn about equations with the variables on both sides? What'd you notice? Well, that they can happen pretty easily, huh? Just depending on you got x in the equation or not. Let's figure out how we do this now. Now, your steps, not much different than we've looked at in the past with SADMAP. First of all, you have to put all the variables on one side of the equation and all the numbers without variables on the other side. That's the main thing here when you're solving variables on both sides. Put all the variables on one side, and then put all the numbers without variables on the other side of the equal sign. Remember, if I'm talking about sides here, it's equal signs. Like this one, for example, 16 minus 2x equals 6x. Well, I need to move this minus 2x over to the other side because I want all my x's over here with their numbers and then all the numbers without x's over there. So we combine variables in like terms. We use SADMAP, nothing big deal there. I mean, it's just the same thing of subtracting, addition, dividing, and multiplying. Add or subtract to get rid of those variables while the numbers stay put. Okay, what about this one? This one's a little different because you've got the distributive property, and that's what you have to do first. Okay, so if you have the 5 on the outside, definitely do 5 times 6 and then 5 times x. Then you're going to combine like variables and use SADMAP. So let's finish this guy out. We've got 5 times 6 and 5 times x. So this becomes 30 minus 5x equals negative 2x. Now, in order to move this minus 5x over to the other side, how do I get rid of minusing 5x? Well, hopefully you said add 5x. You're going to add 5x there. And then you're going to have 30 equals 3x. And I bet you can take it from there. Does that make sense? So the idea, again, is just taking the x's, moving them to one side, and then taking all the numbers without x's and leaving them there. That's it. All right, x equals 10. Why don't you work through these guys? Give you some help here if you need it. You got adding 2x, so how do you move adding 2x to the other side? And you've got y's here and y's there, and numbers here and numbers there. What I would suggest here is that you move the smaller one with the y over to the other side. So minus 2.5y to the other side, and then adding 1 to bring the 6 over to the other side. Now, is it going to work? Yeah, it's going to be the same if you move the 4.5 over to the other side. But I think it's much easier to move the smaller x's or y's to the other side so that it becomes, and you keep a positive number. Okay? Move the 2.5y over to the other side, move the minus 1 over by adding it, and so forth. And then these guys, you got the distributive property all over again. You got minus 2 times x, minus 2 times minus 5, 6 times 2, and 6 times half x. Okay? Need any more help? Well, this one is a lot like this guy once you do the distributive property. And I would suggest, again, moving all of the bigger x's over to the one side, or keeping them put, and then moving the smaller x's away to the bigger x's. All right, well, here are your hints. This is what you should have got. Notice here I didn't divide this out. I just left it as negative 19 over 5. You know what? Just leave it. It's an improper fraction. You know what this is by now. 7/2 and 2. And that's it. How you doing so far? Doing pretty good? Okay, well, let's talk about circles now and some problem-solving questions. Well, these circles have the same area. What's x and what's the diameter? If these circles have the same area, we know that x plus 3 equals 6x divided by 2, right? Because this is the radius, this is the diameter. They have the same area, so most likely their radius and diameter will be the same. So if this is the radius, you got to double it. So 2 times the quantity of x plus 3 would give me 6x. What's the diameter then, and what's x? Here it is. X is 1.5, and the diameter is 9. All right, well, here is an example of how we can use it in the real world, of maybe the price it would be to rent a specific van. Well, this van is $15 a day plus 45 cents per mile, whereas this van is $25 plus 30 cents a mile. When would these vans be the same to rent? After how many miles would you have to drive? Well, what you do is you write an equation for this guy, write an equation for this guy, and then you solve it. You set them equal to each other. So for example, let's do this one. If you want to do it on your own, pause the video and let's do it. Well, this one is $15 plus 45 cents per mile, or X. Whereas this one is 25 plus 30 cents per X. Now what we do here is we put the equal sign in between them, and then we bring the x's over to the one side, and we bring the numbers over to the other side, and then solve for x. That x tells me how many miles it would be before they get to the same. At that point in x, that many miles, that tells us that those two vans are the same price to rent. Does that make sense? Now, personally, I would want this sweet green van. It'd be cool if your mom drove that kind of van. I don't know, would you be willing to be seen in it? I think so. It looks like a sweet chameleon. All right, you kind of getting the idea, guys? I think so. Well, here's what the equation would look like. It'd be about 45 miles with a total of 66 bucks and 67 cents. All right. You able to answer this now? How do we solve equations with variables on both sides of the equal sign? Just move them over. Variables on one side, numbers on the other, and that's it. Well, thanks for joining us as we talked about variables on both sides of the equation, and maybe even talked about sharks. This was Matt with mathsmath.com. Check us out on Facebook at Solving Math Problems, or on Twitter at mathsmath, and enjoy math and riding around in your sweet green van.